Okay, today this video is on section 3.4, arithmetic sequences. So let's first take care of some of the vocabulary that we need to do this. Okay, so the first thing we're going to talk about is a sequence, which is an ordered list of numbers that can form a pattern. An ordered list of numbers that can form a pattern. That's a sequence. Consecutive terms are terms that are one after the other. We talked about that with our consecutive integer word problems. And terms of a sequence are each number in a sequence. Okay, so those are all things that you're going to hear me talk about. There's one more thing. This is an arithmetic sequence. This is, let's do it up here. An arithmetic sequence or arithmetic is a sequence that's a set of numbers that increases or decreases by a constant rate. This is key. If the rate that it increases by is not constant, it's not arithmetic. All right, so here is your formula for an arithmetic sequence. A sub n equals a sub 1 plus the quantity of n minus 1 times d. Now let me tell you what all these pieces are. A sub n is the nth term. That means any term that you choose to figure out, the nth term. A sub 1 is the first term of the sequence. N is the number of the term, like the first term, the second term, so number of the term. And D is the common difference. All right, so let's get into some examples. So here's a sequence. 5, 7, 9, 11, 13, 15. So here's the question I'm putting out to you. Is this an arithmetic sequence? So what you're going to do is you're going to find the difference between each one of the items in the sequence. So 7 minus 5 is 2, 9 minus 7 is 2, 11 minus 9 is down 2. So these are all the same. So that means there is a common difference. So you can say, yeah, this is an arithmetic sequence. Yes, because there's a common difference. I guess that part goes down here, the how do you know part, because there's a common difference. So let's write the equation using that. Okay, this is my first term right here. First term. And this is my common difference. So let's fill in the blanks of this equation. If you remember correctly, here is your formula. Okay, so let's fill in the blank. We have the nth term, so a sub n is equal to the first term, which is 5 right here, 5 plus n minus 1, and my common difference is 2. So if we simplify that, we'll have a sub n equals 5, and I'm going to distribute that 2 plus 2n minus 2. So I'm going to combine these. So I have a sub n equals 2n plus 3. Okay, so now we're going to see what the 1,200th term will be. We're going to plug that in for n. That's the number of terms. So a sub 1,200 is equal to 2 times. Now we're going to put that 1,200th term in there plus 3. So we get a sub 1,200 equals 2,400 plus 3, or 2,403. So what that means is if I kept going in this manner, kept going with my common difference of 2, my 1,200th term would be 2,403. So instead of counting, going up that way, we can use this formula and get us to that number. All right, let's look at number 2. Here you have a sequence. It's asking if it's an arithmetic sequence. So if you check your difference, your common difference, so you're going from negative 19 to negative 14. So you're adding 5. So the common difference is actually negative 5. If you go the other way, let me erase this. This might be confusing. So if you go from this way, your common difference is minus 5 each time. Negative 14 minus 5 is negative 19. There you go. So is it arithmetic? Yes. And how do you know? Because there is a common difference. So write an equation for the nth term. So we have a sub n equals, my first term is negative 14 plus n minus 1, and my common difference here is negative 5. So what will be the 90th term? So we have a sub 90 equals negative 14 plus 90 oops, hold on, let's get the equation simplified first. Hold on. Sorry, I'm one step ahead of myself here. So let's simplify this first. It'll be easier for us. So I have a sub n equals negative 14 plus, now I'm going to simplify, negative 5n plus 5. So when I add these together, I have a sub n equals negative 5n minus 9. Okay, so now we can go back and get the 90th term. Sorry about that. So I'm going to plug that 90th term in there. So I have negative 5 times 90 minus 9. So then I have negative 450 minus 9. So the 90th term is negative 459. All right, let's go on to the next question. We have 2 more to do. Number 3 in your note says, if the 4th term of an arithmetic sequence is 91 and the ninth term is 21, what is the common difference and what is the first term? What will the 20th term be? Okay, lots of things going on here. First, let's use the information that we have to find our common difference. And we're going to make these points. So we're going to make the number of terms your x and the actual number of the term your y. So we have 2 points here. So it's a rate of change. It's a slope. So let's find that slope. Let's take 121 minus 91 over 9 minus 4, and that will give us 30 over 5, and that's 6. So that is our common difference. So D equals 6. Okay, now I'm going to show you a way to find out your first term or your starting point. If we were going to graph this, your starting point would be your y-intercept. So let's set this up like a linear equation there, and we're going to find the starting point or your y-intercept by plugging in one of these points. So I'm going to plug in 91, put in 4 for x. So I have 91 equals 24 plus b. I'm going to subtract 24. So b is 67. So your first term is 67. So we know all of that now. So now let's plug what we know in to get our equation. So your common difference is 6. What's the first term? 67. Now we have to get our formula so we can find the 20th term. So I have a sub n equals 67. That's my first term, plus n minus 1, and my common difference is 6. So let's simplify that. So I have a sub n equals 67 plus 6n minus 6. So when I combine these two, I have a sub n equals 6n plus 61. There's my formula. Now all I need to do is put my 20 in for n. So I have a sub 20 equals 120 plus 61. So my 20th term is 181. Okay? So let's see if you can do the next one, and then I will post the answer for you. So try on your own. Okay, so if you use the points to get a slope, you would have 5 and 50 and 2 and 57.5. You use the slope formula. Here is your slope, which is your common difference over here. Your common difference is a half. So if you plugged that rate of change into a slope-intercept format equation and you used the point to get your y-intercept, you would have your y-intercept is 47.5. Then you would need to plug that into your arithmetic sequence formula. So you end up with a sub n equals 47 plus 5/10 n, or this way, 5/10 n plus 47. That's it for this.